This video is going to be about how to find the image of a region or a curve under a mapping. And this is going to be relevant to Math 2521 and 2621 students. So the two steps that are needed to find the image of a region or curve under a mapping is to first find the inverse of the mapping and then substitute that inverse expression into the original constraint and then simplify. So let's have a look at some examples. First, we want to find the image of the region, this disk, under the mapping z on z plus 2. So first step, we find the inverse of the mapping. And I'm going to assume everyone knows how to do that. So, writing z in terms of w. And then we substitute the inverse into the original constraint on z and then simplify. So we know that z lies on this disk. So now we can substitute the expression for z in terms of w into that constraint. So when we simplify, we get this inequality. Now, letting w equal u plus iv, where u and v are real numbers, we can expand the moduli and obtain this inequality. And we just simplify by putting everything to one side, completing the square, etc. And we find that w also lies on a disk. And so now we can write the image. Second example, this is quite similar but slightly different. We want to find the image of a line, x plus 2y equals 2, under the mapping w equals 1 on z plus I. So first step, once again, is to find the inverse of the mapping. But this time I'm going to expand this out into its real and imaginary components, where the real and imaginary components of z are written in terms of u and v, which are the real and imaginary components of w. Second step, we substitute the inverse into the original constraint on z, and we know that the original constraint on z is x plus 2y equals 2, and that implicitly means the real component of z plus 2 times the imaginary component of z is equal to 2. So we can write this down here. So when we simplify, we see that we have a circle, and so we can write the image as this set here. All right, that's all.